Today we will be talking about inequalities, how to graph them, and how to solve one-step inequalities. So what exactly is an inequality? An inequality is a greater than, less than, greater than or equal to, or less than or equal to. So what a solution to an inequality is a set of numbers that make that inequality true. So let's take a look at 4 examples. X is less than 7. So what that means is we want the set of all numbers that make that true. So that could be 6, 5, 4, 3, 2, 1, -1, -2, and all of the fractions and decimals all in between. So to represent an inequality, we can draw a graph. And a graph is on a single number line. And so our important number here is 7. So we could 2, 3, 4, 5, 6, 7. Okay, so there is 7. We want all numbers less than 7. So what we are going to do is take 7, we are going to put a circle at 7. And then we are going to shade everything less than 7, so everything to the left. This is how you graph x is less than 7. So let's take the next one. X is greater than -2. So here is our number line. Here's -1, there's -2. We want all numbers greater than -2. So let's put our circle at -2. We want everything greater, so it means everything to the right. I'm going to shade that in. Now, we have x is less than or equal to 1. So let's draw our number line. Here's 0, here's 1. Now, since this says less than or equal to, instead of circling, putting a circle around the 1, we are going to put a filled-in circle. That means we're including it because 1 also makes this true. 1 is less than or equal to 1. And then we are going to shade to the left. Now, if we compared that to, say, the first, or this one here, x is greater than -2, the hollow circle, or the not filled in circle, means it does not include -2. Because if you put -2 in here, -2 is not greater than -2. It's equal. And finally, x is greater than or equal to 2. So here's our number line. So we are going to put, since it's greater than or equal to, we're going to put a filled-in dot. Greater than means we are going to shade to the right. Now we can solve one-step inequalities and graph them. Let's take a look at 2 examples. X plus 7 is less than 9. X plus 7 is less than 9. What we first do is we treat it like an equation. We're going to follow the same steps as we did to solve those algebraic equations. We are going to isolate our variable, or the term that the variable is in. We are going to do the inverse operation. We are going to cross things off and then do the math. So for x plus 7, we are going to isolate the x. Plus 7 means we do subtract 7 on both sides. Cross it off. We're going to do the math. 9 minus 7 is 2. We are going to keep the sign and then keep what's left. X is less than 2. Now we can graph this. X is less than 2. So we have our number line. We're going to go up to 2. You don't even need to put the 1. You don't have to put all of them. So if you had, say, to graph x is less than 23, you're not going to put all those little hash marks all the way up to 23. You could just put 0 and then 23 and then shade in. That's a little shortcut. So x is less than 2. Since it's less than, we're going to have an open circle and then shade to the left. Let's do one more example. 3 times p is greater than or equal to 15. We are going to first quarantine our variable and then do the inverse operation. Multiplication multiplication means we now divide. Cross off and do the math. 50 divided by 3 is 5. Let's keep our same inequality, and then we keep what's left over here. P is greater than or equal to 5. So here's our number line. I'm just going to put a 5 because we know 1, 2, 3, and 4 is there. We don't have to put those all in. So now it is P is greater than or equal to. That or equal to means we fill that dot in, and then we go to the right because it's greater than. There is how you graph inequalities and solve one-step inequalities. Now go practice.